Hello everyone, and welcome to our another workshop in the Polaris Hackathon series. I'm Sam from Neo NGD team. Today we have a special workshop on smart contract programming with NeoFS and Oracle. With us is Alexey, the software engineer. Alexey, can you tell us a little bit about yourself and your work?
Yeah, sure. My name is Alexey Vanin. I am software engineer at Neo SPCC. So I'm working on mostly on a NeoFS and for about 4 years, I think. And yeah, I managed a small group of developers. So we are trying to make NeoFS very stable and user-friendly right now.
Cool, thanks. Today we have another guest. It's Stanislav, the new architect, CIO of Neo SPCC. Stanislav, can you tell us something about yourself?
Hello everyone, I'm Stanislav from Neo SPCC. Mostly I'm responsible for the architectural questions and I'm also co-managing the team of developers with Alexey and Leonard, our team leaders. Today I will be on the background and maybe answering questions in chat and maybe helping Alexey.
Okay, thanks. So are you ready to start your presentation, Alexey?
Thank you.
Okay,
So
it's your stage.
today I will talk about oracles, what oracles are, how we as a contract developers communicate with oracles, and how NeoFS distributed object storage can be accessed using those oracles. I will start with a small introduction, and then we are going to write a smart contract which produces oracle call and fetches data directly from NeoFS. Maybe you have seen a great workshop about NeoGo and its features for writing smart contracts in Go language from my colleague Roman. And a couple of days ago, I highly recommend it to get in touch with it. But if you are not familiar with NeoGo or Go language, don't worry. I will go through all steps right from the beginning. And the Go language itself is also known as very explicit language, so you should have no problems in understanding the code if you ever tried writing some code in most of programming languages. So in this workshop, I will be using Go language compiler itself, and also I will use the latest stable NeoGo version and the latest stable NeoFS CLI version to operate with NeoFS. Okay, so this is a screenshot from a Neo website. As you see, both oracles and NeoFS are new features for Neo 3, and they solve very important problems of the traditional blockchain ecosystem. So the NeoFS provides distributed decentralized object storage, which allows to store real data, big data, and assets outside of the blockchain, and use it as a regular object storage, but at the same time having all those distributed decentralized properties. I think I can hear someone. Okay. Can we mute a person here? Oh, thank you. So NeoFS provides distributed object storage, and the oracles allow to access data outside of the chain, making a link between the closed blockchain ecosystem and the data from the real world. So one more image from a Neo website. So Oracle calls are processed by spatial nodes. We call them Oracle nodes that have access to the data source, such as internet, for example, or NeoFS. So Oracle nodes have NeoFS client integrated with them. And smart contract invokes Oracle requests, which are processed by those Oracle nodes, and they request data outside of the blockchain, filter it, and then have to reach a majority consensus. So most of the Oracle nodes should have the same fetched data, the same result. If consensus is reached, then Oracle nodes invoke a callback. This means that the oracles are asynchronous. So one transaction to request the data and one to process the actual result. So the use cases are quite unlimited. So we can fetch sport results to implement decentralized betting platform, predictions, literally anything. And in this workshop, I will go with the use case of multiplayer game. If you ever played multiplayer online games, especially RPGs, you know that important part of such games are items, gears, cosmetics, basically inventory. So blockchain game, this data, this metadata, can be stored and managed by the smart contract. And the actual assets like images, 3D models, etc., and of course the catalog or database of such purchasable items can be stored in the NeoFS. And here we can connect both business logic of item purchasing from the smart contract and the database from the NeoFS. So that's what we are going to do today. Okay, let's start. I did some preparations beforehand, so I have some assets for our game. And there are pictures of items that player can buy, and there is a database file I created for those items. So let's see what inside of it. It is basically JSON, so we can filter it later, and I will cover this detail later on. And what we can see, all items have identity, they split into different categories, they have a title, price. We can expand it with power rankings, for example. The higher the power rank of the item, the stronger your character in the game is. And one of the things is the address. So here is the NeoFS address. So if you're not familiar with it, it consists of two things. It consists of container ID and object ID. So you can think of containers as folders in the file system, directories, or buckets in AWS if you're familiar with it. And the object ID is more like file name. So we can try to fetch this data and see what we got. I can copy it and try to access this data from NeoFS CLI or, for example, from an HTTP gate. So there is one public HTTP gate for the testnet. It is available at http://testnet.fs.neo.org. We can paste our address, container ID, and object ID. So here is our assets. So it's a short that player can buy. One small hint, if you upload objects using NeoFS CLI, it automatically, by default, provides a file name attribute for such objects. And if you are using HTTP gate, it can actually search for a file name attribute. So for example, I can use not the object ID, but actual file name. I think it's called aloha short.png. Yeah, and I can use a nice name of this object instead of object ID. So I have this database, I have the assets, and what I want is to upload this database to the NeoFS so it can be accessed with the Oracle call. So to do that, first of all, I need a wallet. And to deploy a contract, deploying a contract is also operation that I need to spend the gas on. So let's create a new wallet. I did some preparation here as well, but let me show you how you can do that with NeoGo. So you can run NeoGo wallet init with pass to new wallet. You can actually add -a to initiate wallet creation, account creation. So you can do something like that, write a password, and here is your wallet. So you can see its address. But of course, this wallet has 0 assets for now, and for the testnet, you may use such thing like a NeoFaucet service that can give you some gas and Neo to try things in the testnet. So I think it is available at neowish.ngt.network. Yeah, so you can paste your wallet address here, verify your account from GitHub, pass the CAPTCHA test, and you can receive 50 testnet Neo and gas. It is available once in 24 hours, so I already did that today. And let's see our wallet. So this is a wallet I created before. So we can check a balance of this wallet, also using NeoGo. So I think it is wallet nep17 balance command. I specify pass, and I need to specify endpoint to any Neo RPC server. So I will use rpc1.testnet.entry SPCC. Yeah, so this is a NeoGo RPC node hosted by NSPCC, but actually you can use any RPC node you want and see the balance using NeoGo. So as you see, we have 50 gas and 50 Neo on this account, so we can go next. To upload the data into NeoFS, first of all, we need to create a container. And we are going to do that. And to create the container, we need to make a deposit into NeoFS. So creating the container is a paid operation, so you need a little bit of gas to do that. So to make a deposit in NeoFS, you need to transfer your gas right into NeoFS smart contract. So we have a doc site for the NeoFS. I think it is available at cdn.fsneo.org/doc. Yeah. Right now you can see a demo of a CDN service that we are going to launch, I think soon. But right now it's in a testing. And here we stored this website fully on the NeoFS. So this is a test. This website is generated by Hugo, static website generator. Maybe you know that. And it's very easy to generate websites with Hugo. You just write markdown text and choose the template you want, and it creates such beautiful static websites. And with CDN, you can deploy such sites and access them directly from your web browser, but all the content is stored in the NeoFS. Okay, so in this website we have a NeoFS endpoint page, and here we can find some useful information for us. And here we are interested in a NeoFS contract address. So this address is for a mainnet, but we need a testnet. So let's copy that. And we need to transfer gas to this smart contract. We are going to do that again with the NeoGo. So instead of the wallet command, we are going to use transfer. The same wallet has the same RPC node, and we specifying from to account to send assets is going to be our NeoFS smart contract. From our wallet, we should specify token, so we are sending gas, and amount. So let's transfer one gas. I accept. And what's going on now? So we transfer one gas to the NeoFS contract, and it produces notification. This notification is called by in-ring nodes, and they mirror this transaction in the NeoFS sidechain. So if we ask sidechain about our NeoFS wallet account, it should be non-zero as soon as all these transactions are persisted both in the testnet and in the sidechain testnet. So how can we check that? We can ask for the balance using NeoFS CLI. So NeoFS CLI has accounting balance command. We will use this same wallet, and right here we are making request not to RPC node, we want to make request to the storage node, so we want to access NeoFS. And again, in this page we can scroll down and see some endpoints for our storage nodes in mainnet and the testnet. So I can pick any of those, for example the first one. Okay, so we see one. It means that our NeoFS balance has been updated. Okay, so we are ready to create a new container. We can do that. Again, with the command container create. So I won't go into details about what is a container and what is the proper policies for containers. I think it is a great theme for the separate workshop, but a couple of things I should mention. So we want to store the data that should be accessed by the Oracle nodes, so it should be public for reading. But by default, NeoFS CLI creates private containers, so we need to specify basic ACL, and it should be public read. And we should specify policy. It can be any policy. Policy is a property that defines on which nodes the data should be stored. So I'll choose a simple policy rep3. That means replicate all data in this contract in 3 copies. And all the policies that use less than 2 copies are kind of meaningless. So if you're going to create a container, make sure that you have at least 2 copies. Otherwise, the data can be actually be lost. So we don't want to do that. And I'll use await. So what's going on now? We send a request to the storage node, which invokes a smart contract in the NeoFS sidechain. Again, this contract produces notification that is called by inner ring, then approved by inner ring, and it triggers another transaction. So this is also an asynchronous process, and as soon as container is persisted on the chain, we can continue. So this is the ID of our container, and now we can upload an object to that container. So we will use command object put, the same wallet, the same endpoint. We need to specify our container ID, and we need to specify the file. So we will upload our database JSON. All right. So now we have finished everything we need with NeoFS. So we have assets, we have database file there. So now we can go to the next step, is to write the actual smart contract code. So for that, I will create a directory. Okay. So the first thing we need to do is to initiate a Go module. It is an internal Go-specific thing, but it is very simple. We just write go mod command, and we need to specify the name. It can be actually any name, so it doesn't affect the actual smart contract. So let's call it workshop Oracle example. Oops, go mod init. Okay, and after that we can add a NeoGo package. So we are going to use NeoGo as a library to write a smart contract. So the last time I did this workshop, last year, we downloaded we used the whole NeoGo package here, but since then there was some changes, and now there is a interop package that includes everything you need to write as a smart contract, so you don't have to import the whole NeoGo package into your Go mod. So you can just use pkg interop. And yeah, so now we are ready to write some code. I will use my IDE. I use Golang. So let me surpass some output. So it won't. So it won't provide any output to my console. So, and yeah, let's create new file, name it contract.go. Okay. We want to write a smart contract that manages metadata about items of players in the game. So what we're going to do, we are going to define the player type. So every player should have at least balance, and a list of items that this player has. So let's call it items, and it can be a slice or the list of integers. So every item has ID, and here we store our items what player has. So this contract should provide some methods to modify the data, or just to fetch the data. So we can write some functions. We can write balance function that should return the balance of the player, and takes player ID. It can be a string just for simplicity. And we can write items function. And the most interesting for us, we want to write by item function. So it should take player ID. And it should take also the item ID. So this is the interface for our smart contract. Okay, I will omit player registry there, again, just to simplify things. But anyway, we need some players, some data to operate. So I can write a special deploy function. I think it takes data interface and update flag. So this is a special function that is called during deployment stage and also the contract update. As soon as we deploy our contract to the testnet, code inside this function is going to be executed. So for my purpose, I can just define new player there. Let's call her Marie. Let's give her some points to spend, but she has no items at the beginning. And we can store our player data in the contract storage. So to do that, we need storage interrupt. And as we see, to put the data in the contract storage, we need to provide storage context, the key, and the value. So let's first gather storage context. So the key, I think we can use our player ID as a key. So it can be a string. And here we want to store the Mary data in the contract storage. We want to serialize this structure into bytes. And to do that, we need to use std interrupt. And here there is a std serialize method, where we can provide Marie. And this method produces an array of bytes, slice of bytes. So this slice of bytes will be stored in the contract storage as soon as we deploy our contract. So to implement methods balance and items, we need to do a reverse. So we need to get a player from the contract storage. So we can write private function, get player, which takes player ID as the input and returns a player structure. So we need to get from the storage, and get functions takes a context and the key. So we provide context and we provide the key, the player ID. This function returns the data, and if key is not found, so we don't store player with such ID, it returns nil. So we can check it here. And for example, panic that player does not exist. And stop the execution. But if the player does exist, we need to deserialize it back. So here we serialized it into slice of bytes. So this get method returned a slice of byte actually. So how we do that? We call deserialize method, and we need to provide a slice of bytes. So our data, it is an interface in terms of Go. So it is just, you can think about the empty interface as any type. So we need to cast it explicitly to the type that we expect. So we expect there a slice of byte. And this realize method also returns an empty interface, but we know that this slice of byte is a player structure, so we can also cast it to the player. Okay, so we will use these functions to get the player structure. And balance should return the balance. And items should return items. So far, so good. Okay. Now we get into interesting parts. So with the by item function, we want to update our structure, but we also need to check the data from the NeoFS. So let's write some comments on what this function should do. First of all, we need to find the price of the item. So we only have an item ID. So we want to find out item price. So then, as soon as we know the item price, we can check if player has enough balance to actually buy this item. So check if player has sufficient balance to buy an item. And if so, update player structure in contract storage. Oh, that's pretty straightforward. Okay, let's go from one point to another. So find out item price. Database database of such items is stored in the NeoFS. So that is the place where we want to use an Oracle call. How are we going to do that? I highly recommend to look at the examples in the NeoGo repository. So there is plenty of them. So let me open NeoGo repository. And here at examples there, we have plenty of different examples on how you can use different features. And here is the Oracle example. So this example has three methods: request, filter request, and Oracle callback. So basically request invokes request, and the Oracle callback is the thing that we'll cover later. So I think I need this in my code. So Oracle request. So my IDE just automatically imports those, so I don't need to specify them manually. Okay, I will jump to the definition of the Oracle, and as you can see, request has several parameters. So I think we can go one by one and see what we need to prepare for an Oracle request. So we can start with the URL. As the documentation states, the URL is path, the actual URL we want to fetch. So for the internet, for the web, we should specify HTTPS URL. And for the NeoFS, the example is here. So you can see a scheme, NeoFS column, and regular address that we have seen in our database. So just a container ID and the object ID. So, so first of all, let's prepare an URL. We did upload the object a while ago. This is our database, so we need copy that. And we can define a constant. So that's okay. But if you want to write more realistic smart contract, you probably want to update the database as soon as, for example, developers provide new cosmetics, etc. So instead of the constant, we can store our database address in the smart contract storage, and then define some update functions and update this database file, database object, as soon as it needed. So, so I want to store our this address, and let me define a key in the storage. It can be a constant db key. Let's say it will be db, and I need to put db key. So I want to put a string, so my URL. So it should look like, let's call it default db. So it should be a NeoFS semicolon. It should be container ID, this one. It should be a string plus container ID plus delimiter plus object ID. So object ID is this one. So this is our default database. So we can store it in the contract storage, also at deploy stage. So here we can get our URL, storage get. Again, I need contract storage. Actually, I can get read-only contract storage, but that's doesn't matter right here. And key is db key, and the value I store is a string. So this string is fetched there. So we have our URL. What's next? Filter. Database file, this JSON file can be actually really big. So maybe you heard about this case when Rockstar Games, developers of GTA 5, used suboptimal JSON parser in their game. And one day, JSON database of items that can be bought in GTA 5 Online was so big that the parser took like 10-15 minutes to parse this big JSON file. They fixed it, but the point is that those database files can be really big for big games, for example. And we are quite limited in the size of the callback transaction itself, of the Oracle response. So we don't want to actually return the whole JSON file. So we want to return some subset of this JSON file. So to do that, we can use a filter, and a filter is basically a JSON pass filter. So let's try something with this JSON pass. I think JSON pass online, Google has like first link as this JSON pass online evaluator, where you can try to play with different JSON pass expressions. There is a short examples of what can you do, but actual supported JSON pass expressions are in Neo are not so flexible, so I don't think you can use all those features of JSON pass because different implementations actually use different tokens in JSON pass. So we are kind of limited, but we still can filter basic items from the JSON. So we have example here, but I don't want to use this example. I want to try my own JSON that I store in the NeoFS database. So let me actually get that. I can again use my HTTP gate for that. So I have container ID. And I have object ID. So this is the JSON we saw, and I can paste it. And what I want to fetch from this JSON is basically this structure. So the item with the title, address, price, the most important thing for us. So I can write this JSON pass. So I want store, and I want item, and I want to fetch specific item. So again, with for the case of explicitity, we can consider that ID is the position in this list. So item with ID 0 placed in is the first element of the list. So we can use such filter, and let's go back to the code. So our filter can look like this, but instead of the hard-coded ID, we need to provide ID from the parameters. So item ID, but this item ID is integer, and we want to have a string here, so we can just call integer to ASCII method, again in the std package, and here is our filter to fetch the data. Okay. Next, we have a CB callback. So this is the name of the method that will process the Oracle data. Again, oracles are asynchronous, so one method is invoked to produce the Oracle call, and another method is going to be invoked when the oracles fetch the result. So we need to specify the name of the method. We can call that, for example, by item callback. And this method, as it stated here, should have exactly this signature. So actually what I'm gonna do, I wanna return to this example from NeoGo repository and just copy this callback and paste it right there. So it should be called by item callback. Let's see what we got inside. So this callback has those inputs. URL that we used during our request. We have data, we will cover it later. Return code and actual response. So this is a method, it is a public method, so technically anyone can invoke that. But we don't want this method to be invoked by anything other than Oracle nodes. So this first if statement, here we check that calling script hash is actually native Oracle contract. So and then we check if the Oracle was successful. We check return code. There are plenty of them again. You can see like protocol not supported, not found. You can actually process any of those states. But again, now we are not interested in anything other than success, so we will panic at any other status code and the result. So this is going to be our callback. Don't be confused by the letter case. In Go, all public functions should start with the uppercase, so we use uppercase there, and this is a public method. But as you know, in Neo, all methods and contracts actually started with a lowercase, so here we specify the lowercase method name, and here we still use uppercase. What else? User data. We can provide actually any data to the callback function. It can be very useful in our case. So the byItem method is invoked both with item ID and the player ID. And we want to provide this information to the callback to continue our processing. So we can just pass player ID. And the last parameter for this function is the gas for response. So this is amount of gas that should be used to process the callback. And in the example, it is minimum response gas. But in fact, you maybe need a bit more to process this call. But I don't think there are any good methods to find out what exact price you need to pay for your Oracle calls. So probably you need to try different options, different prices to find out what is suitable for you. But I will go simply by doubling minimum response gas. So I think it should be enough for my call. One more thing, request filter should be a slice of byte, so I need to just convert my string to the bytes. And yeah, pretty much it. So we prepared our Oracle request, and this method should invoke it. So the next steps 2 and 3, they actually will be processed not in this method, but they will be processed in the callback. So we can copy them and paste them here. And this is our byItem method. So the callback. Now we need to check if player has sufficient balance to buy an item, but first of all, let's find out what we have at this point. So we passed player ID as an arbitrary data, so it can be accessed from this data parameter. So let's call player ID variable name, and it is data, and we know that this is a string. Actually, it can be a structure, it can be slice of byte, it can be anything. So the result. Result is a slice of byte. So we expect if everything goes okay. So this is the example of the result we expect. So I expect that res contains this string. But we want to parse it actually. We want to fetch the price, and to do that we can use an std JSON deserialize method. So this method we can pass the res, but as you see, the actual result is not a structure, not a dictionary, it is a list. But we don't want to work with lists, so we just want to cut the first and the last symbol in this response. So we will use this and this. So this expression cuts first and the last item. in the response. So we will deserialize actually this dictionary, and as documentation states, JSON serialized return different types according what we pass in the data. So for the maps, it returns map of strings. Strings are the keys in the map, the dictionary, and the interface is a value. So we can again cast it to the string interface. So this is our item that is returned from the Oracle call. Okay. We want to fetch the price of that item, so we can ask for the price. And it is an integer, and we can cast it to the int. So it is our item price. And also we can use ID from this map, which is also an int. Okay. So this is our inputs. Okay. To check a player, we need to use our getPlayer function. We'll use player ID. And let's see if it has sufficient balance. So if player balance is less than item price, we can panic. Balance is not sufficient. But if it is sufficient, we need to update the structure. So first of all, we update the balance. We decrease the balance by the item price. And we update a list of items. So we add item ID to this list. So the structure has been updated. We need to update the value in the contract storage. So we can just copy the code from the beginning. So we need again storage context. And as the key, we use player ID. And as the value, we used serialized value from getPlayer. Okay, so I think this is it. Now we can try to compile this smart contract and try to invoke some methods. First of all, before we compile, we need to define a contract configuration. So as you can see in the Oracle example, there is a oracle.yaml file. So we need to have this one in our code as well. So I create config.yaml. Here we have some information for generating the manifest of the contract. So we can have a name, we can call it any name we want, workshop, Oracle example. We have source URL, we have supported standards. I can ignore that. We do not support any standards like NEP 17 or NEP 11 in this contract, but you can specify them if you want a compiler to check if the standard is correctly implemented. If your contract produces notification, you also should define them in these events. And our contract does not produce any notification, so we don't need that as well. So actually, the only thing we need is to specify the permissions. It's permissions to any methods that we call outside of the contract, methods that actually change the contract state. And in our example, basically, the only method we call is the request method of the native Oracle contract. So we have to specify it there. Otherwise, NeoGo compiler will not compile our contract. So let's go to the console. To compile the contract, we can use contract compile command. There are several inputs, so we specify contract, the contract.go -i with -c we specify config, and there are two outputs. So basically we want to see the manifest file, manifest.json, and we can overwrite the name of the actual bytecode file .nef, but I don't want to do that. So as you see, as an example, as a result, we have contact.nef and manifest.json. So we are ready to actually deploy this contract. So to do that, we will call contract deploy and provide the contract bytecode, manifest, wallet, and RPC. So we will use the same RPC, rpc1.testnet 3 SPCC room. And yeah, I need to pay 10 gas, and here we are. So this is our contract address, and at deploy stage I expect that contract already has a Mari player in the contract storage, so we can check it with the NeoGo contract test invoke function. So this thing generates an RPC request to the remote node to execute a method, but it does not produce any actual transactions. So basically we need to specify endpoint, again the same. Contract and the method. So we had, for example, balance method, which takes one parameter, which is a string, player ID. So I can invoke that, and as you see, RPC node returned information about this invocation, state held, and on the stack we have an integer with the value of 30,000. So if we invoke items, we see an empty array. So Marie has no items here. So now we want to produce the transaction. So instead of test invoke function, we will use invoke function. Now we have to specify the wallet to sign this transaction. So it should be wallet JSON. So the method is by item, I think, and we need to provide two things there: player ID and the item ID. So player ID is going to be Marie, and the item ID, we have 6 items. Okay, let's call it 4. So what's happening right now? We sent the transaction with invocation of this method by item. As soon as it is reached, it persisted in the blockchain. Then Oracle node should make an invocation into NeoFS, find our database JSON file, filter it, and invoke a callback method. So as soon as callback method will be invoked, it should check the balance. I think we have enough balance to update our data about Marie. And let's try to see if it worked. So we can call again test invoke function balance. And as you see, the balance has been decreased. So basically callback method has been invoked. And now there is a non-empty array with the item with integer 4. So the test invocation, the Oracle call was successful. It read the data from the NeoFS, filter it correctly, find out the correct price of the item with ID 4, and updated the contract storage. So that's pretty much it. I think one more thing I want to cover, that as for the HTTP oracles, it's basically the same thing. So the only thing that difference is the actual URL. So instead of NeoFS URL, you can specify general website, HTTPS, and it should work the same way. So thank you for your attention. I think you can ask any questions if you have.
Yeah. Thanks for Alex's presentation, and all the audience. If you have any questions related to today's topic, you can write your questions in the devlog test channel, and Alex and Stanislav can answer them. So personally, I have a question for you, Alex, or Stanislav. I'm not quite good at coding, but this is a general question. What's the advantage of NeoFS comparing to the centralized file storage system? Why we should use that decentralized file storage system?
I'm afraid I couldn't hear your questions.
Yeah.
Maybe Stanislav?
No, I tried to understand, but I think it's better to type them in chat.
Yeah. Yeah. So here is my question.
Oh, now I see it.
Yeah.
So the advantage is that you have full control over your data, and if we see the example covered in this particular workshop, you can reach more fault-tolerant goal compared to what you can do with a self-hosted centralized server. And for the decentralized game, you can have your data stored in the more flexible way compared to, for example, some centralized cloud storage solution.
Okay. So you have more control about your what you own, right? So anyone else, if you have any questions, please type it into the this devlog test channel. If not, this workshop we will finished. So 1, 2, 3. Okay, seems nobody have any questions at all. So if you have any other questions, free to ask them in the NeoFS channel or devlog channel. The dev from Neo SPCC will answer them when seeing that. Thanks all the participants, and thanks all the audience. This is today's workshop. Thank you all. So Yeah.
Thank you.
Yeah. Maybe we have another questions. Maybe we can quick answer that. Is it possible that someone gets my data from NeoFS and exports it? For example, clone the items and stuff from games?
That's the same way as if you host them on any platform available for the client. So you can limit the access rules using the ACL to, for example, make it available only from your application. But if the item is downloaded some way by the end user, of course it can be copied just like anything.
So you have to set the access to your data when you upload it in the NeoFS. So any other questions?
I'm not sure I heard it correctly because of the voice lags. But in NeoFS, at least, you have very rich access control list language. So you can control the access using, for example, the bearer tokens that you specifically issue for your application, and that will make your data to be distributed only to the designated clients. So, but you can do the mechanism not allowing to get the data by anybody knowing the link or knowing the address. So that's possible, of course. And in this way, it's more secure than regular HTTP, for example. And from the other side, it works in a decentralized. It still works in a decentralized setting. So, if you, for example, distribute your replicas according to the geographical positions of the players of your game, the rules are controlled by all those nodes. So you can store data close to your players and still have all the security guarantees that you define.
Okay. Okay. Thank you for your answer. I think that's all of the today's workshop. Thank you all the participate, and thanks all the audience. Thank you. Bye bye.
Thank you.
Thank